All right, y'all. So we've talked about redox reactions, right? This idea that something has to be oxidized and something has to be reduced, right? There are two parts to a redox reaction. But because of that, we can balance redox reactions, and we have to do that based on these two different parts. Okay, so when we balance redox reactions, the first thing that you do is split into half reactions, and you know what a half reaction is because they would look alike. So it's going to be similar stuff on the product and reactant side, group those together. And then you balance each half reaction. The big thing here is that the number of atoms and electrons on both sides have to be the same. Again, the reason we balance equations is because of this law of conservation of mass. Okay, so we have to make sure it's balanced. Once you're done, you multiply each half reaction to cancel electrons. You want to make sure that you have the same number of electrons on both half reactions. Again, we'll work through a problem in a little bit. And then once you're done, you add those half reactions together. Okay? And then you clean stuff up, cancel things that need to be canceled out. And anytime you balance, honestly, any kind of reaction, specifically redox reactions in this case, make sure that the sum of stuff on the right side equals the sum of stuff on the left side. Sum of stuff on the products equals sum of stuff on the reactant side. Okay. The thing that I think trips me up, I guess, a lot as well, and a lot of students too, is, oh yeah, the masses are the same, and then I don't check the charge. Or yeah, the charge is the same, and then I don't check the masses. So always make sure that your charge and mass are balanced. Okay, all right. So here's an example. Okay, so here's my reaction, and I want to make sure that it's balanced. So the first thing that I'm going to do is split it up into half reactions. And so these numbers here just indicate the oxidation states. Okay, so it kind of helps you see, hey, what is being oxidized, what is being reduced, is stuff staying the same, like where are we at? And in this case, you'll see that this is being reduced, and oxygen, hydrogen are staying the same, so we can ignore those. And then iodine is being oxidized. Okay, it's going from -1 to +5. Okay. All right. So when we write out our half reactions, we're going to have the oxidation half. So whatever is being oxidized, we write that out. Whatever is being reduced, we write that out as well. And so in this case, what is being oxidized is my iodine. And so it's I and that. Okay. And whatever is being reduced, in this case, is my chlorine. And I write it out as that. So literally all I've done, so I've added electrons here, but all I've done is I pulled this out and I pulled this out and wrote it here. I pulled my chlorine out, that's on my reactant side, and I pulled my chloride and put it on there, and we're good. Okay, and so first thing I do is pull those out. Then I add the number of electrons to kind of balance stuff out on both sides. So I'll talk you through this. Whatever you're going to work through is not going to be as complicated. The big idea here is pulling out your half reactions, okay? And then putting your electrons on there. Big thing here is that your mass and your charge need to be balanced. And so when I go to write this out, this is my complete oxidation reaction. I have 6 things of chlorine here, 6 here. They look different, but it's still the same number of atoms, okay? I have 1 thing of iodine, 1 thing of iodine here. I have 6 things of hydrogen, 6 things of hydrogen here, and 3 things of oxygen, okay? So always make sure your masses are balanced. Mass is balanced, we're good. Let's check our charge. So the overall charge here is -1. And the overall charge here is -6. -1 plus 6, -6 plus 6 cancel out. I'm left with that. Okay. What you guys are going to deal with is not going to be this complicated. You're not going to be using oxygens and hydrogens. You're just going to be using the different masses, two different elements. And I'll work you through a problem in a little bit. But the big thing here that I want you to take away is anytime you're given a reaction, a redox reaction, you got to make sure your mass is balanced as well as your charge. Okay. So here is my half reaction. I don't want to go through this in too much detail because you're not going to see something this complicated, but the big thing here, so I have 6 electrons here, I have 2 on this side. I want to make sure they cancel out, so I'm going to multiply this by 3 to get, so I can cancel stuff out. Okay, And so this is my overall reaction. You want to make sure that electrons cancel out. Again, nothing that complicated on the exam. This is the type of question that you would expect, excuse me, to see on the exam. All right, so let's go ahead and balance this equation. The first thing that I want to do is split it out into half reactions. Okay, so these two go together and those two go together. This has an oxidation state of 0, -1, -1, which means that's being reduced. And this has 0 plus 3. This is being oxidized. In the grand scheme of things, I don't care that you put these things there, right? This should hopefully just help you think about, okay, it's being oxidized, then my electrons need to go on my product side. Oh, it's being reduced. My electrons need to go on my reactant side. All right, so for iodine, let's write it up here. I2 to give me 2 I's. Okay, that's my iodine. And then for my aluminum, this is where I'm at. Okay, right now, masses are balanced, right? I have 2 things of iodine here, 2 here, life is good. 1 here, 1 here, life is good. But my charges are not balanced, and I need to fix that. For my iodine, I have a total of -2 here. The only way I can balance electrons is by adding electrons. And so if I have negative or balanced charge is by adding electrons. If I have a -2 here, and I add a -2 to that side, it's going to be -4. That's not what I want. And so I'm going to add my negative electrons to that side. Now I have a balance of charge, right? -2 here, -2 here. Okay. On the flip side, if I have a positive here, again, the only way I can balance it, I have a +3 is 0 here. I can add my electrons to the product side. So the reason it's important, it is important for you to identify what is being oxidized and what is being reduced, could help you with the putting where to put the electrons. So if something is being oxidized, you should be adding the electrons to the product side. If it's being reduced, you should be adding the electrons to the reactant side. Again, if you just stop and think through it, you don't need to have that memorized. You'll just figure it out. All right. The next step is to add these reactions together, but in order for us to do it, the number of electrons have to be the same on both sides. This is not the case here. And so to fix that, I'm going to multiply this by 3. It's going to give me 6 electrons. And I'm going to multiply this by 2 to also give me. And for this, I have 6 electrons plus 3 things of iodine to give me 6 things of the iodide ion. Okay. And so now I can add these 2 things together, literally by just putting whatever's on each side together. Okay. If I have stuff on the opposite side, if they're the same, I can cancel them out so my electrons can go away because they're on opposite sides of the arrow, and I'm left with 2Al plus 3 things of iodine to give me 2Al3 plus and 6I. So things on this side I add together, and things on this side I add together. Let's check our masses. 2 things of aluminum, life is good. 6 things of iodine, we're good. Overall charge here is a 0. Overall charge here is a +6, -6, which is 0. We're good. We're balanced, charge and mass. That's my balanced equation. Okay. All right. Go ahead and work through this. So just pause it, go ahead and work through it. Make sure that you are able to, and I'll talk through the answer in like 2 seconds. Okay. So again, first thing you want to do is write out your half equation. So anything that looks the same is going to go together. And so AU goes together, AG go together. I add 3 electrons to this side because it's being reduced. I add 1 electron here. I add 3 because there's a +3 here, -3. I add 1 here because there's a +1 here. I just need 1 more. But in order to add them, I need to have the same number of electrons on opposite sides. So I'm going to multiply my silver by 3. Which then helps me to cancel out the electrons. So these electrons will cancel out, and I'm left with the AU and 3 things of silver, AU here and 3 things of silver. My charges are balanced. My mass is balanced. Okay. And there you are. Again, what you will see on the exam in terms of balancing redox equations, what you will see on the exam is going to be that straightforward, like that question that we just worked through. It's just two elements, to kind of have reactions, and you add the electrons to whatever side, multiply, and then add them all together.